nearly a century, model trains were all controlled the same way. A variable transformer would be connected to the track, the train would pick up electricity through the rails, and the higher the track voltage, the faster the train would go. Modelers dreamed of having realistic sound and independent control of multiple trains, but that wasn't possible without expensive and complicated gadgets. But eventually, technology finally started to catch up. Digital Command Control, or DCC, was developed in the early 90s by the National Model Railroad Association. They asked various companies to submit designs for a digital train control system, and the winner was Lenz Electronics of Germany. Although the name is trademarked, DCC is an open standard, which means all manufacturers are allowed and encouraged to make their products compatible with it. This is in contrast to a proprietary standard like Lionel TMCC or MTH DCS, which are owned by a specific company and no one else can sell compatible equipment without a license. DCC powers the track with alternating current at a constant voltage, and commands are sent to a decoder in the locomotive by varying the length of each voltage pulse. All of this happens so fast that the trains respond to commands pretty much instantly, and because each decoder has a unique address, you can send commands to multiple trains and they won't interfere. I've been using DCC in HO scale for years, but when I recently started getting into O gauge, I discovered that DCC isn't nearly as common as it is in other scales. Granted, this wasn't entirely surprising. By the time DCC was invented, O gauge already had a long history of doing things differently from every other scale. For example, analog control in O gauge typically uses AC power, while most other scales use DC power. Another thing I haven't seen in most other scales is that many O gauge models, especially cheaper ones, are built smaller than true scale size so they can handle sharper curves. Like many of the oddities of O gauge, such as three-rail track, this is a holdover from the days of tin-plate toy trains more than 100 years ago. The reason it has 3 rails is because these early trains were made entirely of metal, and there was no good way to insulate the wheels on each axle from each other. You need 2 separate electrical connections to power a train, so in this case the 2 outside rails would both be wired to one terminal, and a third rail was added for the other, along with a pickup roller on the bottom of the locomotive. This 3-rail system was used in several different sizes, but O gauge was the only one to make the transition from toys to scale models, thanks to Lionel's 700E Hudson locomotive in 1937. Most scales used today, such as HO, were developed later after plastics had improved and it was possible to insulate the wheels. This removed the need for a third rail, but by this point 3-rail O gauge was well established, and to make new O gauge trains compatible with older ones, they had to be able to run on 3-rail track. Eventually, separate standards were established for 2-rail O gauge, but in North America at least, it never became nearly as popular as 3-rail. With the introduction of DCC, it was inevitable that O gauge would eventually get some kind of digital control. Instead of adopting the DCC standard, Lionel developed its own proprietary system, which they called Trainmaster Command Control, or TMCC. Lionel's biggest competitor, MTH, followed suit with their Digital Command System, or DCS. Both of these systems provide independent control over multiple trains with sounds and lights, but they're not designed to work with DCC or with each other. It is possible to use them both on one layout at the same time, and there's even a workaround to operate TMCC trains through a DCS remote, but most Lionel models have a lot of features that you can't access this way, and it's a far cry from having one universal system. Lionel did license TMCC to a few other companies, such as Atlas and K-Line, but since MTH stuck with DCS and refused to license it, there was no hope of settling on a universal standard. Meanwhile, since DCC is an open standard, all brands of DCC controllers will work seamlessly with any brand of decoder, and the decoders in most locomotives can be easily swapped out with no soldering required. Lionel has since replaced TMCC with a more advanced system called Legacy. Although legacy locomotives will run on the old TMCC system, you need a legacy controller to access most of the features. Of course, almost all O gauge models will still run on an analog transformer, but just like running them on TMCC, you're paying for features you can't use. Certain Lionel locomotives can also be operated using a Bluetooth app, but this feature was only added a few years ago, so most of the models on the used market don't have it. So if you want to run multiple brands of O gauge trains, you have 3 options. 1, you can buy 2 different expensive proprietary systems. 2, you can go back to analog control and lose all the fancy features, including the ability to control 2 trains on the same track. Or 3, you can do what I did, what O gauge manufacturers should have done 30 years ago, and bring DCC to the 3-rail world. It's a lot easier to install DCC in an O gauge locomotive than it is to swap in Legacy or DCS, and it's often cheaper than buying a comparable ready-to-run model. This is a Lionel Mikado from 1996. Despite its age, it's one of the best-looking scale models Lionel has ever made. It's also the most accurate model of Southern 4501 that was ever mass-produced, not including brass. Most models of 4501 are actually USRA Mikados, which are pretty close in overall appearance but have some noticeable detail differences. Although these were available with TMCC as an option, this particular one didn't have it. Instead, it came with an analog sound system that only worked some of the time and sounded pretty goofy when it did.
Whistle works. Bell works. Bell won't go off. Anyway, see if we can get it moving. Nothing. Still stuck in neutral. Try again. Nothing. And of course now, I set up to film this test from another angle, and it works again.
My first idea was to swap Legacy into it, but since Lionel doesn't sell Legacy electronics separately, the only way to get them is to part out a working locomotive, which would be absurdly expensive and I'd still be left with an incomplete model. MTH has sold Protosound 3 upgrade kits before, but they're hard to find, expensive, and frankly, the sound quality isn't that great. I also don't have a DCS or a Legacy controller, and didn't feel like spending hundreds of dollars for one when I already had a spare DCC system just lying around. Now, if you've had your finger on the pulse of the O-Gauge world lately, you're probably asking, well, what about Blunami? For a little context, Blunami is a line of DCC decoders made by Soundtrax, one of the biggest names in the business, that can be operated with a Bluetooth app as well as a normal DCC controller. Blunami is a spin-off of the long-running Soundtrax Tsunami line of sound decoders, hence the name. Several other YouTubers have made excellent videos on installing Blunami, which I'll link to below. While it is definitely a good option, I decided against it for 3 reasons. First, and this is purely a personal thing, but I do not like touchscreens. I find it very annoying to use buttons with no tactile feedback, and I like being able to memorize controls by touch so that I can use them without looking at them. That's why I drive a 2006 Toyota Camry. It's definitely not because I spend all my money on trains, no sir. I also frequently film trains with my phone, so using it as a controller at the same time isn't really practical. I did get a chance to try out Blunami at a train show recently, and I actually found the app to be surprisingly well designed and easy to use, but I'd still rather just have a normal DCC controller. The second reason is sound. While Blunami does sound pretty good, there are other decoders that, in my opinion, sound better. Of all the ones I've tried, TCS Wow Sound is by far my favorite. There is a module you can buy called Blu-rail that allows any DCC decoder to be controlled by the Blunami app, but that leads me to reason number 3. The whole point of Blunami is that all it needs is track power and the controls are completely separate from the layout. This is great if you want to take your locomotives to a club layout or a friend's layout, but in my case, I don't know anyone locally with an O-Gauge layout, so my locomotives are probably not going to leave this one very often. It made more sense to just wire the layout for DCC and use normal decoders. If I ever do want to take them to a different layout, I can always add the Blu-rail module. For layout power, I'm using an NCE 5-amp booster, which is enough to comfortably run 2 O-Gauge locomotives at once, and I'm using a power cab as a throttle. This setup works pretty well, and I can add more throttles later if needed. I've converted 2 locomotives to TCS Wow Sound so far, and I have a third one in progress. I've also upgraded the speakers in these models and given them a good servicing to make sure they're running at their best. The second locomotive is an MTH Alco RS1. This model has 2 motors, which I wired in series instead of the original parallel setup, and that makes the engine run slower and reduces the amp draw. I highly recommend this mod for any dual motor diesel, even if you're not converting it to DCC. The third locomotive is an MTH USRA 060, which I got for a very good price because the drawbar wiring was messed up. If you want to convert O-Gauge trains to DCC, you can save a lot of money by starting with non-running models like this one, since whatever part is causing the issue will probably get removed in the conversion anyway. Alright, that's enough technobabble. Let's take the Mikado for a spin and see what all the fuss is about. First of all, check out the smooth low-speed creep. TCS decoders have absolutely incredible motor control, and this is a prime example of what it can do. I did replace the motor in this engine, which helps, but the electronic wizardry of TCS can make almost any motor run much smoother than it normally would. Will notice something else about TCS Wow Sound that no other sound system has, not even Legacy. With most sound decoders, you're hearing a loop of the same 4 chuff recordings over and over again. For example, take a listen to this Lionel TMCC steam engine from the mid-2000s. If you've never noticed that before, you probably won't be able to unhear it now, so my apologies. Wow sound, on the other hand, has a huge library of chuffs that it randomly shuffles, so you're never hearing the exact same pattern twice. This gives it a much more natural, varied sound and gets rid of that obvious loop effect. To my ear, this sounds much more like a real steam engine. Another thing it does really well is varying the intensity of the chuffs depending on acceleration and load. Most sound decoders do this to some extent, but Wow Sound does it better than any other brand I've tried. TCS also has some cool features that aren't sound related. All DCC decoders, as well as Lionel and MTH, have some sort of momentum setting, but TCS Wow Sound takes it a step further. By default, the deceleration momentum is turned up very high, so when you shut off the throttle, the train keeps coasting for a long time. You can then press function 7 to apply the brakes, and each time you press it, it applies 20% more brake. You can press it once or twice to make a long, slow, smooth stop. Or if you're running out of track, you can just spam the button a whole bunch and it'll stop very quickly. The brakes automatically release when you apply the throttle again. The Lionel Legacy system does have a brake feature, but it works differently and doesn't simulate real train brakes the way the TCS decoder does. Now let's have a look at the RS1. This model originally came with MTH Proto Sound 2, and because I don't have a DCS controller, I was only able to run it in analog mode. Now, not only does it have better sound, but the whole operating experience is much more realistic. Here's the startup sequence on the original Proto Sound 2. And here's the startup with Wow Sound. Now, while it does undoubtedly sound better, a lot of that is just down to the upgraded speaker. But don't worry, I haven't gotten to the best part yet. Most sound-equipped diesels are programmed so that the diesel engine RPM is tied to the speed of the train. When it reaches a certain speed, the engine will rev up to the next notch, and as you reduce speed, it'll notch back down. Seems simple enough. The problem is, that's not how a real diesel locomotive works. There's no physical connection from the diesel engine to the wheels. The engine generates electricity, which powers the traction motors, so the engine RPM and the speed of the train are completely independent. Unlike a truck with gears, it can hold a steady RPM while accelerating, and the engineer can throttle up the engine to generate more pulling power whenever it's needed, or back off and let it coast, regardless of how fast the train is moving. TCS Wow Sound is one of the few systems that bothers to simulate this correctly. The decoder measures the load on the motor and the rate of acceleration, and notches the engine up or down depending on how hard it's working. If we start off from a stop with a heavy train attached, it will rev up several notches as it accelerates, then back down to a moderate RPM to maintain the requested speed. Sometimes it'll rev up a notch or two when it enters a curve, since that puts more friction on the wheels and increases the load, and it'll notch back down when the track straightens out. It gives the impression that there's actually a little engineer in there, monitoring the speed and adjusting the throttle as needed. conclusion, I realize that DCC and O-gauge isn't for everyone, but hopefully I've inspired a few other intrepid mad scientists to experiment with it. There is also a lot more you can do than what I've done. DCC can be tied in with computer control, signal systems, switch machines, and most large-scale decoders can operate a smoke unit as well. I'm using 5 amp decoders, which are designed for G-scale models, as opposed to the little 1 amp decoders used in HO scale. Because they're made of die-cast metal and thus very heavy, most O-gauge steam engines draw just as much current as G-scale ones, sometimes even more. The Blunami 4408 decoder, the one people generally use for O-gauge Blunami conversions, tops out at 4 amps, which is adequate for most O-gauge applications. There are also ESU Locksound 3 amp and 5 amp decoders available. If you like the sounds of Blunami but want to save a little money, you can also get a 4 amp Tsunami decoder, which has the same sounds but no Bluetooth. Now, I mentioned something earlier about these DCC conversions being cheaper than a comparable ready-to-run model, so let's add it up and figure out just how much cheaper they are. I'm going to call the cost $200 to $250 for a conversion. You could probably do it for a little bit less if you keep the stock speaker. I paid $200 for my RS1 on eBay and about $300 for the Mikado, both including shipping. That means the total cost, as they sit right now, is about $400 to $450 for the RS1 and about $500 to $550 for the Mikado. A brand new MTH RS1 goes for around $400, which is actually an okay deal for what it is, but that does come at the cost of features and sound quality. The closest thing Lionel makes is probably the Legacy GP20, which retails for $650, and while Lionel's sound is much better than MTH, TCS WOW sound still blows them both out of the water, especially for diesels. The closest thing to my 4501 would probably be the Legacy USRA Heavy Mikado, which retails for an eye-watering $1,300. Some dealers do offer discounts, but usually no more than 10 to 20% off. Used examples can be found for less, of course, but even an older Legacy Mikado without Bluetooth will run you $800 in decent shape. It is worth noting that MTH ProtoSound 3 models, like that brand new RS1, will run on DCC out of the box, and I believe they're the only O-gauge locomotives to do so. MTH has announced that they're working with Atlas on some new models that will also come with ProtoSound 3, including a gorgeous 280. But I'd rather not pay $800 for ProtoSound 3 when I could get a used Legacy engine for the same price, or buy an older model and put WOW sound in it like I did with the Mikado. Now, if you just want to run trains with really good sound and cost isn't an issue, Lionel Legacy is still probably the best option. It does have some features that are hard to find anywhere else, like the quilling whistle feature. DCC does have the ability to do this, but it hasn't been implemented in very many decoders. Legacy sound also includes crew talk.
Dispatcher, made up and waiting on the clear track. Can I go? Over. Hold for track orders. Out.
Personally, I usually turn it off even on models that do have it, but if you like it, that's another point for Legacy. Some DCC decoders do have an option for it, but not all of them. Legacy models also usually have excellent speaker setups with tons of bass, especially in the larger steam engines. The good news is that you can have your cake and eat it too. Legacy uses wireless control, so even if your layout is set up for DCC, you can run Legacy trains on it at the same time, although if it's an older model without Bluetooth, you will still need a Legacy remote. Anyway folks, I need to wrap this up because I said in conclusion earlier and then kept on talking, but hopefully you found this video entertaining and maybe even educational. I don't necessarily think DCC should replace Legacy and DCS, but I do think it has a lot to offer that the O-gauge world is missing out on, especially that diesel auto-notching feature. But at the end of the day, this is just a hobby, and you're doing it right as long as you're having fun with trains. If you've tried DCC and O-gauge, or if you're thinking about trying it, I'd love to hear about it in the comments. If you have questions, suggestions, or corrections, feel free to drop them in the comments as well. I'll see you next time, folks. Please subscribe, and thank you for watching.